So far, we've seen how to add pre-packaged automated checks to our deployment process using Git pull requests and GitHub's branch protection rules. Now, it's time to lay the foundation for our own custom automations by introducing GitHub Actions to our repository. If you're not familiar with continuous integration or with GitHub Actions, there are links in the lesson notes to help you get started. Essentially, we will be creating a new markup file containing our custom automation logic to our repository, and GitHub will automatically invoke that logic whenever certain events occur. The best way to understand what I mean is to see it in action, but there are a couple of setup steps we must take first. In your Salto account, you will need to generate an API token. We do this because we will be using Salto's command line interface in our GitHub Actions. So GitHub needs a way to authenticate to our Salto account so that it can interact with our Salto deployments. If you already have a Salto token, you can use that. Otherwise, click on your profile, settings. In the user section under API token, click Generate. This will prompt you for authorization and show you a new token one time. Make sure that you copy it and keep it in a safe place. Next, we need to give GitHub our token information. In GitHub, click Settings, Secrets and Variables, Actions, then select New Repository Secret. Place your token string here and give it the name Salto API Token in all capital letters separated by underscores. Now we are ready to add our GitHub Actions workflow. In your repository, click Actions, followed by Set up a workflow yourself. This takes us to a text editor containing an empty YAML file named main.yml. Again, check the lesson notes for resources if you are not familiar with YAML. We will walk through and add the necessary code to this file line by line, but the full version is also attached in the lesson notes. First, we give our workflow a human-readable name to make it easily recognizable. Then we give it a more machine-readable name. Both names can be changed to whatever best fits your system. Now, we use the on element to set which events in the repository will trigger our workflow. I want to trigger the workflow anytime a pull request is added or updated, but I only want to do so when the branch is one of our Salto before branches. If you recall, this is the same pattern I used when I created our branch protection rule. Next, we add the job that will be invoked by our workflow. The job is what contains the actual automation steps, but first it needs an operating system. I'm going to use an Ubuntu Linux distribution. Now we're ready to add our steps. The first step is installing the Salto command line interface, which we do by downloading and extracting the Linux executable. That's all it takes to install, so we're ready to run commands. Every time Salto updates a deployment pull request, I want to automatically regenerate the preview of that deployment to make sure it is still valid and deployable. We can do that through the Salto CLI using the deployment preview command, like so. We tell the command which deployment to use by passing it the name of the current branch, which GitHub conveniently provides for us in the GitHub head ref environment variable. Finally, the Salto CLI needs our authentication token, which, if you recall, we stored in the Salto API token secret, which you can access in your script. And that is the full contents of our file. It's time to commit this to our repository. I am committing to the main branch with the file name main.yml, but you can use any file name or any branch that you like. Typically, you will use the primary branch or some other long-lived branch in your repository. Go ahead and commit your file. Back in Salto, we need to tell Salto where it can find our workflow configuration. Under Settings, Version Control, at the bottom we see CI/CD configuration files location. It is here that we tell Salto which branch we committed our YAML file to. I committed on main, so I will select main here and add my automation. Now, anytime our deployment pull requests are updated, GitHub will automatically run our workflow, which generates a preview of the pending deployment. If that preview fails for any reason, our pull request will not be mergeable, and thus our deployment will not be deployable. Now, this is barely scratching the surface of the kinds of automations and validations that we can perform with continuous integration systems like GitHub Actions. I encourage you to study continuous integration and GitHub Actions, as well as the other commands and operations that are available in the Salto CLI. You will find links in the lesson notes to help you continue this automation journey.